So earlier I have started soil design of raft in clay. One is your partially compensated raft in clay, that means particularly for raft foundation. As I said, there are many number of columns are there. So B by L is known, B by L is known. So then depending upon your partially compensated raft, so DF you have to assume, depth of the foundation. From there you have to find it out net load intensity. Then Q average you calculate, it will be given every 1.5 meter interval or 2 meter interval. Then DF by B, B by L, based on that you find it out your shape factor. Once you get the shape factor, from there you can find it out net ultimate bearing capacity. Then net load intensity, once you know net ultimate bearing capacity from the soil properties, once you know, find it out factor of safety. If you are getting a factor of safety of 3, then there is no change in depth of the foundations. If factor of safety, if you are not getting factor of safety of 3, modify the depth of the foundations. This is part 1. Then part 2 is your find it out your settlement. The settlement calculated, it should be less than settlement permissible, right? If you are getting with first part of your depth of the foundation assume with your settlement less than permissible settlement, then your bearing capacity governs. That means it satisfies settlement as well as bearing capacity. That means the design criteria completely governs with your bearing capacity. For example, after satisfying your bearing capacity, for example, if is your settlement is calculated settlement is greater than your permissible settlement, then you have to again modify your depth of the foundations till you are getting rho is equal to rho permissible. Then in that case, if rho is greater than rho permissible, that is, in that case we can say that it is the case where your settlement governs particularly your raft foundations. Then there is a floating raft. Floating raft generally if load intensity is not given, there are multi-story buildings, then load per floor is 12.5 kilonewton per meter square. Raft which are backfilled that is called your floating raft, and it should be designed as per my earlier one, as per your footings, as per your footings. So if I raft foundation design categorically mention into 3 parts, one is your dimensions, second is your check bearing capacity, settlement permissible, then third one is your structural design. Let us go to one example. This is example. In this case I started with a very small one, 6.11 meter, and raft size is 30 meter by 50 meter, and this will be dead load plus reduced live load. With dead load is given 120, reduced live load 84, which comes out to be 204 mn. So what is there? What has to be find it out? For the floating raft in clay shown in figure A, what you have to find it out? A, the net load intensity producing permissible settlement is the net load intensity producing settlement is your 60 kilonewton per meter square. To find depth of foundation, simple one I have started with this, and the B also determine the depth of foundation For full compensations, there are two parts B. Find depth of foundation for full compensation and partial compensation to factor of safety of 10, 5, 3, 2 and 1 on net ultimate bearing capacity. Then second part is your simple one I started, factor of safety if gross load intensity increases by 25, 50, 75 and 100% at a constant depth of foundation of foundation of 7 meter. So, very simple. The raft size is given 30 meter by 50 meter and dead load and reduced live load is given 204 meganewton. First one is the net load intensity producing settlement is 60 kilonewton per meter square. Find the depth of the foundation, and part B there are two sections. Find depth of foundation for full compensation and partial compensation to factor of safety is equal to 10, 5, 3, 2 and 1 on net ultimate bearing capacity. Second, factor of safety if gross load intensity increases by 20, 50, 75 and 100% at a constant depth of foundation of 7 meter. Let us start with GLI, gross load intensity 204 meganewton into 1000 divided by 30 into 50, it comes out to be 136 kilonewton per meter square. Let us go to the shape factor. Shape factor is equal to 1 plus 0.2 30 by 60, which is equal to 1.12. So, start with part 1 A. So, for net load intensity is given what? Net load intensity is given 60 kilonewton per meter square. So, net load intensity, if I write it, net load intensity is equal to gross load intensity minus gamma df. The gamma is given here 15.2 kilonewton per meter cube, and considering this is equal to 60, gross load intensity is equal to 136 minus 15.2 into df. So, your depth of foundation is equal to 5 meter. So, now also you consider df by b, how much? df by b is your 5 by 30, which is equal to 0.17, nc is equal to 5.4, then soil bearing pressure SBF is equal to QU by 2. So, also QU is given, QU average is given 42 kilonewton per meter square, QU by 2 into NC by factor of safety into 1 plus 0.2 B by L. So, if this is my shape bearing capacity is 60, then QU is equal to your 42 by 2, NC is equal to 5.4 by factor of safety into 1.12. So, factor of safety is equal to 2.12, which is less than 3. Then what does it mean? Revise your DF. So, first one is not satisfying. Considering the net load intensity and other part, it is not satisfying. If I taking into this, if you look at here how I have started for part 1, gross load intensity calculated. Gross load intensity is what is the load is given 204 meganewton into 1000, it is Newton, divided by your area 30 meter by 50 meter, it is coming 136 kilonewton per meter square. Shape factor is your 1 plus 0.2 B by L, it is 1.12. So, net load intensity is given 60 kilonewton per meter square. So, net load intensity is equal to gross load intensity minus gamma dF. From there I am getting dF is equal to 5. At the same time, I will have to find it out your soil bearing pressure. Considering soil bearing pressure is equal to 60, QU value is given NC and this is your shape factor, then factor of safety is coming less than 3. So, you have to revise this factor of safety. Then you consider take dF by B is equal to 0.2, NC is equal to 5.5. So, SBP is equal to 42 by 2 into 5.5 by 3 into 1.12, which is equal to 43.12. Then you consider this is your net load intensity. So, from there you find it out, net load intensity is equal to your gross load intensity minus gamma dF. From there you are getting depth of the foundation is equal to 6.11. Now you have to check dF by B is equal to 6.11 by 30, which is equal to 0.2, it is okay. Now for part 1, adopt dF is equal to 6.11. So, in the first case, case 1, taking into depth of the foundation 5 meter, it is not satisfying. Our criteria of factor of safety is equal to 3. Now, considering dF by B is equal to 0.2, NC is equal to 5.67, 5.5, soil bearing pressure comes out to be 43.12. This same soil bearing pressure has been assumed as a net load intensity. Providing net load intensity is equal to gross load intensity minus gamma dF, dF is equal to 6.11. Now checking dF by B is equal to whether it is satisfying 0.2, because this is our assumption. So dF by B is coming exactly 0.2, hence depth of the foundation comes out to be 6.11. There is no assumptions, it is coming out from the net load intensity and gross load intensity. Now come to the part B, parametric study. dF at full compensation So, net load intensity is equal to 0, full compensation means there is no backfilling, net load intensity is equal to 0. So, from there I am getting 136 is equal to 15.2 into dF, gamma dF. So, dF is coming out to be 8.95, and considering with this dF, factor of safety tends to infinity. So, depth of the foundation at factor of safety is equal to 10 and QU is equal to 42 kilonewton per meter square. So, then you have to find it out. Assume dF by B is equal to 0.27, NC is equal to 5.6, then SBP soil bearing pressure is equal to 42 by 2 into 5.6 by 10 into 1.12. This is your shape factor 1.12. That comes out to be 13.17 kilonewton per meter square, which is equal to net load intensity. So, considering this, your dF is coming to be 8.08, and you can check it, dF by B is equal to 0.27. It is okay. Now, depth, similarly you can find it out considering factor of safety is equal to 5, and similarly you can get it. Then factor of safety at dF is equal to 0. So, in this case dF by B is equal to 0, NC is equal to 5.6. So, from there you can calculate SBP is equal to, calculate it, and dF is equal to 0. Then net load intensity is equal to gross load intensity, which is equal to 136 kilonewton per meter square. Then with considering this is equal to either net load intensity or gross load intensity, then from there you can find it out, factor of safety is equal to 0.89. If I draw it, this is my factor of safety. So, it will be 1, this will be 2, 3, and this is completely 10, and this will be starting from 1, and this will be your 9. So, this is your 0.89, and it tends to infinity. So, this will be a 1, 2, 3 and up to the 9. So, this is what this parametric study has been asked for different factor of safety. For different factor of safety, you can find it out what is the depth of the foundations. Factor of safety is given 10, 5, 3, 2, 1. Then you can find it out for full compensations. Full compensations means net load intensity is equal to 0. Then you can also find it out, this part I leave it to you. Factor of safety if gross load intensity increases by 20%, 50%, 75% and 100%. That means here gross load intensity is given 136, increase is 20%, increase 50%, increase 75% and increase 100%. Then also you can find it out, this part I leave it to you. Come to your next example, example 2 for raft. These are the size has been given, column loads also given. This is what it is given. This part is your 12 meter, this is your 16 meter and raft is your 14 meter by 18 meter. Raft is 14 meter by 18 meter because here 12, this side will be 1 meter, this side will be 1 meter, that is why it is 14. Here 16, this side will be 1, this side will be 1, that is why it is 18. Load is given 720 into 10. How it is 10? 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 into 4 it is 20, and here also 20. So, altogether it is given 720 into 10 plus 560 into 10. So, this comes out to be 12,800 kilonewton. How many number of column loads are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Out of the 20, 10 column load is 720 kilonewton, another 10 column load is 560 kilonewton. That means interior column load is 560, outer column load is 720 kilonewton is there. Now, at the same time, there is a subsoil profile also given. This is 0, this is 4, this is 15, this is 19. So, and water table is at located 0.5 meter. This is your delta, and layer 1 is your farm clay, layer 2 is your soft clay, layer 3 is your stiff clay, and N is greater than 50. Gamma value is given 18 kilonewton per meter cube for all 3 layers, for all layers, and gamma submerged is given 8 kilonewton per meter cube. So, you just consider it, though it is given gamma is equal to 18 kilonewton per meter cube, here gamma is 19 kilonewton per meter cube, then here gamma is 18 kilonewton per meter cube, and what other values has been given? Here in this case Cu is given 50 kilonewton per meter square, Cc by 1 plus E0 which is equal to 0.03, and here Cu is equal to 30 kilonewton per meter square, Cc by 1 plus E0 which is equal to 0.08, then here Cu is equal to 80 kilonewton per meter square, and then Cc by 1 plus E0 which is equal to 0.08. This is what your subsoil profile is given. This is your raft. There are total 20 column loads are there, and load is given outer periphery it is 720 each column, interior columns are 560 kilonewton, total load is coming 12,800 kilonewton. So, from there you can find it out, raft size is given 14 meter by 18 meter. So, Q load intensity is equal to 12,800 divided by 14 into 18 which is equal to 50.8 kilonewton per meter square. So, initially start with assume value of your depth of the foundation, assume depth of the foundation is equal to 1.5 meter, and check your bearing capacity. NC is equal to 5.8. So, if you look at here, this is my zone 1, this is my zone 2, this is my zone 3. If I put it here in this way, and this is my 14 meter, this is my pressure bulb, then what will happen? Major portion of the pressure valve lies in zone 1 and zone 2, and if I compare with zone 1 and zone 2, major portion lies in zone 2. So, that means NC is equal to 5 6. So, either you take, in case of zone 2, either you take Cu is equal to 30 kilonewton per meter square, or you can say Cu average considering 1, 2 as well as 3. As a design engineer, I look at major portion of the where it is lying, it lies in the zone 2. I am considering Cu is equal to 30 kilonewton per meter square. So, Q net Cu NC, which is equal to 30 into 5.8, which is equal to 174 kilonewton per meter square. So, factor of safety is equal to 174 divided by 50, which is greater than 3.0. Now it is okay. Bearing capacity has been satisfied. Now go to your immediate settlement as well as consolidation settlement, then we will check whether it is satisfying or not. Now if I take it immediate settlement, so B is equal to 14 meter, Qn is equal to 50.8 kilonewton per meter square, mu is equal to 0.5, Ip is equal to 1.2, Cu average considering 3 layers, it considering 1 plus 2 plus third layer, it comes out to be 43 kilonewton per meter square. E is equal to, I have considered 700 Cu, which is equal to 30,000 kilonewton per meter square. So, immediate settlement it comes out to be Qnb by E 1 minus mu square into Ip, which comes out to be 0.21 meter. Similarly, if I consider for consolidation settlement, first one is your immediate settlement, second is your consolidation settlement. In consolidation settlement, this part I leave it to you. In consolidation settlement, you consider this one A at the middle, this is at the B, this is at the C. Consider 3 layers, find it out your consolidation settlement. So, I am just, you can check this consolidation settlement, I leave it to you. I am just reviewing this step. So, it will be 0.03, it is for layer 1, 1.5 into log 10 33 plus 49.8 divided by 33 plus 0.08 into 12 log 10 8.1 plus 37.5 divided by 8.1 plus 0.06 into 4 into log 139 plus 178 divided by 139, which is equal to 188 mm. So, there are 2 corrections in your consolidation settlement. One is your rigidity corrections, how far it is rigid, it has been taken as 0.8, depth corrections also taken, it is 1.0, then pore pressure corrections, pore pressure correction which is equal to 0.7. So, rho corrected, consolidation settlement rho corrected is 0.8 into 0.7 into 0.188, which comes out to be 105 mm. So, total settlement, total is equal to immediate plus consolidation, which is 126 mm, more or less it is same as 125 mm, that means it is okay. So, this is a case of not fully compensated. When net load intensity is equal to 0, it is a partially compensated. In that case, as I explained earlier, floating raft, it is a case of a floating raft, very simple. It will be designed like a footing. So, in this case straightforward what I have done it, raft size has been given, load has been given, load intensity has been calculated, net load intensity has been calculated, assuming a value of depth of the foundation 1.5, then net load intensity is coming 174 kilonewton per meter square. Here you considering pressure bulb, I found that the zone 2 is most of part of the pressure bulb covering complete zone 2. Either you can consider CU considering zone 2 or you can take CU average of zone 1, zone 2 and zone 3. So, factor of safety is coming about to be 3.0, which is okay. Now, calculated the immediate settlement calculated, immediate settlement B is given, Q net load intensity is given, IP is given, CU average has been considering, layer 1, layer 2 and layer 3 has been calculated, E modulus of elasticity has been taken into 700 CU, which is 30,000 kilonewton per meter square. Load immediate settlement is coming out to be 0.21. Consolidation settlement considering 1, 2 and 3, this part I have given. Of course, I have given the detailed calculations. Here is a P0 plus delta P by P0, P0 plus delta P by P0. It comes out to be 188 mm. There are generally 3 corrections applied. One is your rigidity, how rigid it is. So, rigidity corrections is your 0.8, then depth correction is your 1, pore water pressure correction is 0.7. Based on that, rho corrected is 100, consolidation particularly consolidation settlement correction is your 105 mm. Total settlement is comes out to be 126 mm. As per the BS Bureau of Indian Standard Code, the permissible settlement required is 125 mm. Now it is okay. The size and the depth of the foundation is okay. The last part is your structural design. This part I will solve for one case either in a retaining wall or footing. So, you should have some structural design basic knowledge. So, I will solve one problem, then it will taken care of everything. So, I will stop it here. Next class I am supposed to start a new chapter, earth pressure or earth pressure theory or maybe deep foundations. So, thank you all of you. So, we will meet in the next class.